Welcome to Luxoft Tech Talks, a series of podcasts in which IT gurus share their knowledge and discuss the latest trends and innovations in the world of IT. We are going to cover the most recent developments in the programming languages, frameworks, and technologies that are shaping the future of the software industry. This new format of online learning is part of Luxoft Learning Management and Development Services rebranding. Please share your feedback in the comments to let us know what speakers and topics you would like us to cover in later installments.
Hello everybody. Welcome to this presentation about Java behavior-driven development with Cucumber. I am Catalin Tudose and I am going to demonstrate the most important ideas that are staying behind the behavior-driven development implementation with Cucumber. The objectives of these sessions are that you as attendees will understand the fundamentals of behavior-driven development, and we are going to show how to make the step between an application that has been built with tests, with test-driven development ideas in mind, to the behavior-driven development. We'll show you the basics of Cucumber and how to develop a Java BDD application with the help of this Cucumber framework. Who should attend? Our targets is represented by developers who are new to BDD or developers that have understood behavior-driven development and want to work with Cucumber, or even testers who need to automate a part of their activity. Why did we arrive to behavior-driven development? We have to say that behavior-driven development has its roots in test-driven development. This TDD is a wonderful technique, but it comes with some limitations. TDD comes with the idea of test code refactor in mind. So you start by writing the test that is initially failing, then you write the code that is making the test pass, and then you eventually refactor your implementation. This is a very good thing, but it comes with some shortcomings. First of all, tests are tightly coupled to the implementation. So you have to understand at the level of class and methods what it is happening, and you have to write tests to address methods in particular. So your focus will be on methods or on the class that are tested. Of course, why? Because you are looking for doing things right. You would like to make sure that you are doing the things right. But here there is a danger. There is a danger that you neglect the business goals and you do not see the overall picture. You do not understand, you do not know how the software should act as an assemble. So what is behavior-driven development? Behavior-driven development is a methodology for developing IT solutions that are directly satisfying business requirements. So you have the business requirements or the business goals in your mind, and you would like to develop the IT solutions looking at these business requirements. So whenever you are writing software, your focus is to add business value to the application. So you would like not only to make the things right, but you would also like to make sure that you are doing the right thing, that you are doing something that is adding business value to the application. And BDD is also facilitating the communication between the business analyst and the developer so that they should have a common understanding about what needs to be done. How do we describe the requirements? How do we communicate between the business analyst and the developer? Usually we are communicating through scenarios. So here we have illustrated two possible scenarios, saying, as a usual customer, I want to get an economic credit offer so that I can apply for it. As a VIP customer, I want to get a business credit offer so that I can apply for it. In this case, the key expressions are as a, I want to, so that. As a expresses some preconditions, I want to expresses some actions, so that expresses some consequences. And according to these ideas, we would like to present how we can apply for an offer, for a credit offer in the application that we are going to use as a vehicle for our demonstration. And we have an application that is providing credit offers to the customers. And we would like to apply for the credit offer. So if you would like to add the customer to the credit offer, first you ask yourself, is the credit offer economy? If the credit offer is economy, we immediately approve the request. If the credit offer is not economy, we should also ask ourselves, is customer VIP? We will approve a non-economy offer for VIP customers, and we are going to reject the credit offer, the non-credit offer economy for non-VIP customers. And we would like also to see the business logic for removing a customer from the credit offer. If the customer is VIP, we reject the request. So once we have assigned a VIP customer to a credit offer, we cannot remove him or her any longer. If the customer is not VIP, we will be able to approve the request. So this means that we'll remove the customer from the credit offer. And we are looking now at what are called automated acceptance tests. We would like to implement this feature, customer's policy. The bank follows the policy that we have already seen, the policy of adding and removing customers, depending on the credit offer type and on the customer type. And what we have already seen as schemas, we would like to summarize within scenarios. One of the possible scenarios will be summarized as following. Scenario economy credit offer, usual customer. Given there is an economy credit offer, when we have a usual customer, then you can add and remove him from an economy credit offer. So what you have already seen as the business logic embedded into the previously presented schemas is summarized into this scenario. Maybe you have already noticed that the parts of the test are given, when, then. Given represents the preconditions. So we start with some situation, we have some existing conditions, and we are doing some actions. This action is expressed through the when keyword. Then we are expecting some consequences, and we are presenting them through the then keyword. What is also important in measuring the quality of our tests is the code coverage. The code coverage is a measure used to describe the degree to which the source code of a program is executed when a particular test suite runs. It is important that this code coverage is as high as possible. And I can tell you that usually in side projects, there are special requirements that the code coverage is at least 80%. We may ask ourselves, which code coverage percentage is feasible? 80% is some general minimum requirement for most of the projects. But we can ask ourselves, can we get to 90% at least? Can we get even to 100%? What I can tell you from my practical experience is that in most cases, you can reach 80% without much problems. 90%, the step between 80% and 90% is pretty hard to achieve, especially when you are getting closer to 90%, it may be hard to write tests that are covering the remaining parts. Can we achieve 100%? In most cases, this is not feasible, but even if it is hard or really unfeasible, you may think about trying to get as close as 100%. Why? Because it is possible that that piece of code that remains untested hides some real problems. And you would like to have your code covered as thoroughly as possible. And there is some bad news. The bad news is that even if you achieve 100% code coverage, it does not mean that your code works perfectly. Why? Because of a few reasons. First of all, it is possible that your tests are not perfect. Your tests may not be the best quality. So you may cover pieces of your business code, but you may not test exactly what needs to be tested. So you may not have a safety about what you are testing and if this is really high quality. In this case, there are techniques that may control the high quality of the test. Here, just keep in mind the idea of mutation testing. We are not going to discuss about this during our presentation, but this is a technique to be kept in mind in order to verify the high quality of tests. We are going to direct ourselves to the presentation of behavior-driven development, and we are going to show how we start from an application that is tested TDD or test-driven development way, and how we are moving ourselves to the BDD style. So let's move now to the practical demonstration, and we are going to show our initial application, the application that provides business credit offers and economic credit offers, and to show the status of how the tests are done, and then to make the step towards BDD. So we have an application that has a customer class. A customer has the name, a Boolean field saying if it is VIP or not, with the constructor and the getters. We have an abstract credit offer class having an ID of the credit offer and the list of customers that have applied for it. You may get the customers list. You may add or remove a customer from the credit offer. And this credit offer abstract class has two subclasses. First, it is economic credit offer. And we see here the logic. We may add a customer to the customers list that have applied for this economic credit offer with absolutely no restriction. While here, for the remove customer method, we may remove a customer from this list only if he or she is not VIP. We look at the business credit offer that also extends credit offer. And we see that here the add customer method logic says we can add a customer to the customers list that have applied for this business credit offer only if that customer is VIP. Otherwise, we cannot add him or her to the list. And remove customer will always return false. So once you have applied for a business credit offer, it means that you are a VIP customer and you cannot be removed from there. Let's have a look at the tests. We have here bank test. And if we look at the methods, we'll see here test economy credit offer usual customer. So what we have to understand from here is that we have an economy credit offer, we have a usual customer, and we would like to test the add and remove operations. So we are constructing an economy credit offer. We are constructing Mike as a usual customer. And we are starting to make some assertions to see if the ID of the credit offer is fine, to see if we have been able to add Mike as a customer to the economy credit offer, to see that after Mike has been added to the economy credit offer list, the size of the list is 1, to see that Mike is really inside the list of the customers. Then we try to remove Mike from the economy credit offer list. This operation should be successful and the size of the list should be 0, meaning that there will be no more customer to the list. So this is testing adding and removing a usual customer to an economy credit offer. The second method we have here, test economy credit offer VIP customer. So what we're expecting is to test the behavior of the add customer and of the remove customer method with an economy credit offer and a VIP customer. How are we doing this? We are creating an economy credit offer. We are creating John as VIP customer. We check the ID of the offer. We check that after adding John, the operation is successful. We check that the size of the list after adding John to the economy credit offer is 1. We check that John is inside the list. Then we try to remove John, who remember is a VIP customer, from the economy credit offer list. This operation should be unsuccessful according to our business logic. And the customers list should be unmodified, 1. So this is the test for economy credit offer and VIP customer. The test business credit offer usual customer. Here we have a business credit offer, Mike, who is a usual customer. We test that after adding Mike, trying to add Mike to the business credit offer, the size of the list remains 0 because Mike could not be added. If we try to remove, of course, we cannot. We do not have any Mike to be removed, so the size of the list will remain 0 and the operation will return false. And finally, we have test business credit offer VIP customer, saying that we have a business credit offer. We have John, who is a VIP customer. If we try to add John to the VIP, if we try to add John, who is a VIP customer, to the business credit offer list, the operation should be successful. The list should have 1 element. If we try to remove John from the business credit offer, the operation should be unsuccessful and the size of the list should remain 1 because we're not able to remove him from the list. So this is how we have covered all the possibilities from our business logic. Remember that we have presented the business logic with the help of some schemas. So what do we see here? We see here that we have 1, 2, 3, 4 tests, and this is natural to have 4 tests because we have 2 possible credit offers. We have 2 possible kinds of customers. 2 multiplied by 2 equals 4. So we should have 4 tests. Let's see how these tests work. Let's execute the whole suite, not only just one test. Run bank test. It takes a little time. So what we see is that all 4 tests have been successfully executed, and we can see them here, and we can read them. Of course, the names of the tests are significant. We have awarded to them, we have assigned to them significant test names. Test business credit offer usual customer, test business credit offer VIP customer. But this is to show that the tests and the code are really tightly coupled. If we change something in the names of our methods or in the names of our business class, we should come here and also modify the test in order to synchronize them, to synchronize how the business code looks like and to synchronize how the test code looks like. We have discussed about code coverage, and I'm going to execute this test with the whole suite. In fact, let's execute the whole suite with coverage. We see here that the code coverage is 100%. We have tested everything. We are really lucky in this case because the business logic allows us to test up to this limit of 100%. Usually this is not possible, but for our business logic, we're lucky enough so that we are able to bring our code coverage up to 100%. Let's have a look at the configuration of our project that allowed us to run it and to obtain this 100% code coverage. I'm going to look here into the pom.xml file, which is the configuration. What did we need to insert here? We needed to insert the dependencies to JUnit Jupyter API and JUnit Jupyter Engine. These are the dependencies to the JUnit 5 framework. We have everything with the help of JUnit 5. What else did we insert here? We inserted here this Jacoco Maven plugin. Jacoco means Java code coverage, and it is a library that allows us to run the tests and to obtain the code coverage, as you have already seen when we run those tests with code coverage. So what we may conclude so far is that we have a pretty solid application. It does what it needs to do. It is well tested. We have 100% code coverage, but it also has some shortcomings, meaning that our tests, our four tests need to are tightly coupled to our business logic. And it is not so easy to read the test unless we keep the names of the test synchronized with the business logic. We are at the level of test-driven development. This is fine from the TDD point of view. We are making sure that our code is doing the things right, but we should ask ourselves, how do we address the business logic? How do we make sure that we always do the right thing, meaning that we really address the business needs and that our business logic is providing business value? And this is how we are going, this is what we are going to do next, trying to migrate from this TDD approach to the BDD style and then to the BDD approach with the help of Cucumber. Our next step will be to move to the BDD approach. And we are going to do this first with the help of only JUnit 5 and its capabilities. We remind that we have this application here that has a customer class, has a credit offer abstract class that is extended by economy credit offer and by business credit offer. See? And the big change that we made is at the level of tests. What do we see here? We'll have a very quick look here from top to down, and you see that there is a really big difference from our first approach where we had 4 tests. So let's have a look. This is how the old tests were looking like. How did we do this? First, we used the annotations that are provided by JUnit 5. You see that we have this display name, and now we may assign to any test class or to any test method some label. And we have already used the keywords given, when, and then, so that whenever you see a method or a test being executed, you may see what it intends to do. And we do not care much now about the exact names of the test methods. They remain the same, but we may change them easily. And we are going to remain with these explanations with the help of the display name annotation. And we also used nested tests. So this means a test inside another test. And we have, remember, we have 4 types of tests. We have 2 credit offers, economy and business. We have 2 types of customers, usual and VIP. And we have 4 kinds of tests. And we have embedded them nested level. So we have here economy credit offer test nested inside the big bank test. And inside this test, we also have another class, nested. We annotate it with nested. So this one has one method, and the other method related to the economy credit offer has been moved to another nested class. Each test and each nested class has its own label provided by the display name annotation. What else did we do here? We have used this assert all method, that it is asserting everything at once. If you have a look here, you may recognize that practically they are the same tests that we have used, the same assertions that we have used for our previously existing TDD approach. But when we write this inside an assert all method, we should understand first that they are grouped, and then there is another advantage. Even let's say that here one test will fail, assert all will also execute the remaining ones without stopping. Previously, without the usage of assert all, if there was a failure here at this assert, let's say, the remaining ones were not executed any longer. And you see, we already have some logical grouping, so we may already think that we have a view about the business needs, about the business logic. Let's execute the tests, how they look like now. They run bank test. It will take a little. Okay, tests are green. That's very good. But what is very important is that we are able to read the execution of this test in a fluent, coherent way, just like reading the scenarios that we have discussed about in case of behavior-driven development. So you may read here, given there is a business credit offer, when we have a VIP customer, then you can add him but cannot remove him from a business credit offer. Given there is an economy credit offer, when we have a usual customer, then you can add and remove him from an economy credit offer. So you have a good understanding of how the business logic addresses the business needs. And these scenarios may be the basis of the communication between the business analyst and the developer. We no longer have some tests that are only focusing on testing the methods and the classes themselves, but we have these tests that are having some view about the business needs and how the scenarios, how the application is interacting with its end user. Let's have another look here. What we have used from the JUnit 5 annotations, of course, this test annotation that was previously used, even without this approach with nested classes and the display name. Nested, we said that we may have test inside the test, and this helps us a lot, especially when we have tightly coupled tests. Display name, and we have a freely chosen label for each class and for each test, but we are following the terminology of the behavior-driven development using given, when, and then. And also this assert all method may have a label saying here verify all conditions for usual customer and an economy credit offer. So we have separated the labeling from the names of the methods and from the names of the class, and we have brought them at the informative or meta information level of the annotation. So you see here how they look like, nested and related by logic. Last but not least, we also have this before each annotated methods that are making the setup for all tests from inside a class. So all tests from inside this nested economy credit offer test will have the same setup, creating an economy credit offer, usual customer Mike, and the VIP customer John. And we are isolating here the overall setup for all tests from a particular suite. Let's run them with the help of code coverage. And you see that our code coverage remained at the level of 100%. We are saying that this is not compulsory, but as we were having 100% in our previously existing test, BDD test, of course, we would like not to lower our code coverage. We move to a better approach. We move to some BDD with JUnit 5, not yet introduced Cucumber, but of course we would like to have the same code coverage and in general the same quality of the tests. And here you see that we have kept them at 100%. So we have made a first step towards BDD, but for the moment only with the help of JUnit 5 and its capabilities. No particular framework, no Cucumber so far. If we look here in the configuration in POM XML, we'll see the same dependencies, the same JUnit 5 dependencies, and the same Jacoco Maven plugin, Jacoco Java code coverage that helped us running the test with code coverage. So we have made one first step towards the implementation of BDD. We are going to move to the Cucumber approach. We move now to the pure BDD approach using Cucumber. And we remind you that we have an application having a class customer with a name and Boolean VIP, an abstract class credit offer, that is extended by economy credit offer and by business credit offer. And we have just introduced this customer policy dot feature. This is a Cucumber file where we may find the description of the feature and the scenarios that need to be addressed by our application. What you see here, it is a plain text file and it is written in plain English. Of course, you may write it in some other language if you would like, but you need to keep these keywords: feature, scenario, given, when, and then. Otherwise, you may write here the description of the scenarios, the feature, the steps in whatever language you would like. Of course, we are using here English. And this is something that a business analyst may provide the developer. This may even result from the discussion between the business developer, between the business analyst and the developer. So we may write how our application should act in plain English. So feature customers policy. Description: the bank follows a policy of adding and removing customers depending on the credit offer type and on the customer type. Scenario: economy credit offer, usual customer. Given there is an economy credit offer, when we have a usual customer, then you can add and remove him from an economy credit offer. And another three scenarios of the same kind. In fact, they are the scenarios that we have already seen. First, in the logic schemas that we have presented, then at the level of the tests, but we are working first BDD and then we started to move to BDD. We may imagine that these four scenarios correspond to the four tests, to our four initial tests, or to our four nested tests that we have shown in our previous demonstrations. But the big advantage and the big change here is that you can read them in plain English, just following this file, just like any story. How do we move from the code, from the scenarios to the code? We may have a look here. This is the implementation of the scenarios at the level of the code. What we are using here, you see some new annotations. These are Cucumber annotations. So besides our previously introduced JUnit 5 annotations that we have discussed in more detail a little earlier, we are introducing these specific Cucumber annotations. And we see the keywords are translated at the level of the annotations, and we have the given, then, and when as Cucumber annotations. So what should we follow here? So you see, you may read this annotation and you will immediately see that it is corresponding to this line from this scenario, to this step from this scenario. So you may imagine that when you are executing a scenario, each step from the scenario will be translated at the level of a method annotated with the corresponding annotation. So you read here, given there is an economy credit offer, and you will translate what it means that we have an economy credit offer. We initialize this economy credit offer with the help of the constructor. When we have a usual customer, we translate this at the level of the code. Mike is new customer of Mike and false. Then you can add and remove him from an economy credit offer. This is translated to this method, annotated this way. And we are making our checkings here with our previous assertions. So you see that we can easily follow the steps at the level of the code, or if we are not interested about the code, or if we don't master the code, for example, if somebody is business analyst, it will suffice to read these scenarios here into the feature file. So we are translating from here to the code corresponding with the corresponding annotations. What we see here that we have this step, given there is an economy credit offer, twice here. Of course, there will be one single method annotated with given there is an economy credit offer here. So we may shorten the code. We remove the code doubling, we make some economy, and our code is clearer. Okay, this is the translation of the 4 scenarios at the level of the code. How do we execute the tests? We need to introduce this Cucumber test class. What we see here is that it does not contain many lines. It says here, this class should be empty, step definitions should be in separate classes, more exactly here in the customer policy class. So if we come back here, we just have some meta information at the level of the annotations that we run some tests with the help of Cucumber, some options about Cucumber that it should look for the features on the class path in the folder features, and this is to be found right here. I remind that the folder test resources is included into the class path by Maven, and then here we should look into the features folder, and here we discover this customer policy feature. It has to have a corresponding customer policy.java with the same name, and we'll be able to execute it. Let's run this Cucumber test. It'll take a little, of course. And you see here we have this way that the scenarios are working. You can read them in plain English. Scenario, economy credit offer, usual customer. Given there is an economy credit offer, when we have a usual customer, then you can add and remove him from an economy credit offer. If we look back here into our previously simulated BDD, but only with the help of JUnit 5, let's rerun the bank test. We see here that we have the nested tests, because remember, we were using this nested annotation. While here, using Cucumber, you see them one after the other, and they are even easier to be read. We don't count here that we already have the scenarios written in full text files, and anyone with a minimal understanding of the business that we would like to implement will immediately understand what it happens. Okay, how do we arrive here? What do we need? Let's look into the POM XML file to see what dependencies we have added. So besides the JUnit Jupyter, meaning the JUnit 5 dependencies, we see also these these two dependencies that represent the cucumber dependencies. So these ones were needed as we needed to use these annotations. Let me look for the test file, as we needed to use given, when, then annotations. So these are the cucumber dependencies. And of course, we do not forget about this Jacob Maven plugin here. We remind that we can run, with its help, we can run tests with code coverage. Let's try it now. Run cucumber test with coverage. What is important is that we have remained at our 100% code coverage. We are saying that this is not compulsory, and in most cases you will not achieve such a high level coverage. But what it is important for our demonstration is that we have started with 100% code coverage. We moved from that TDD approach to the incipient BDD simulated only with the help of JUnit 5, and we are still having 100% code coverage. And now, as we have introduced this cucumber approach, we remained at 100%. So the code coverage remains the same. Of course, this is very important, and we were able to simplify to make our tests easier to follow and to understand. You may ask yourself here, but how do we know how to annotate these things? How do we provide this parameter to this method? Let's presume for a moment that this method does not exist here. Let's say that we are at the beginning of our demonstrations. And we'll show here that we are able to run feature customer policy directly the feature file. I think it needs some configuration here. It needs some glue and some feature or folder paths. The glue means the name of the package, com.luxoft.bdd.bank, and the feature, we are going to select it from here. It is exactly the feature file that we have just seen, customer policy feature. Let's try to run this now. You see, you are able to execute directly. What's happening here? Say undefined step. Remember that we have removed one of the steps annotated with given there is an economic credit offer. And you see here, you can implement missing steps with the snippets below. And you can simply take the method from here, move to the implementation, and we'll introduce this step here. You see that this is having the same annotation. So if you are wondering how you can generate this file, you see that you may directly execute the feature file, and you may get the initial annotated but empty methods. So you have here some indication. You have to write the code that turns the phrase above into concrete actions. So you have to write the code that turns this given there is an economic credit offer to concrete actions. But remember, we have already done this. and I'm going to uncomment here this previously existing method. This was the piece of code that was turning this phrase into concrete actions. Let's see if we can run now this customer policy feature directly. Okay, you see this time we have successful green tests, 4 scenarios, 12 tests. They are corresponding to everything that is to be found here. So you also see here some big advantage. Some non-technical person or less technical person like a business analyst can run the feature file very easily. Just right click and we have executed this customer policy feature directly. So we have moved from our initial TDD approach to the simulated BDD, meaning we say simulated BDD because we're not using any framework like Cucumber or nothing else. We're just using the pure JUnit 5 annotations and its capabilities like display name and nested. And then we have moved to this Cucumber, which is a BDD framework. And you saw how nice we can test our application. We have these scenarios that are easily understood both by the business analyst and by the developer, and they may be executed by any person, even with less technical preparation, and we have translated these scenarios at the level of the code. So I would say that we are concluding our demonstration about Cucumber and its capabilities. I think you will be able to clearly see the advantages of adopting behavior-driven development in practice, in particular, the advantages of adopting Cucumber in practice. And I hope that you have enjoyed our presentation. Thank you for watching.